Somebody help me. Life is going nowhere. Somebody help me. Life is going nowhere. Somebody help me. Never mind, I got this.
All right, today we're going to be looking at functions. Our objective is to identify a function when given a table of values or a set of ordered pairs, and then identify the domain and range if the ordered pairs represent a function. So, I'm going to give each group a picture collage of 5 different vending machines. Along with the collage, each participant will have a note sheet. Okay. So everyone take a look at picture number 1. Okay? What I'm going to ask you all is, when you choose an input, will you know exactly what you will get out? So, looking at this vending machine, what would be some inputs? What's one input? What we type in to the vending machine? D5. Okay. So if we put in D5, what will we get out? Hershey. Okay. The Hershey bar. All right. So we put in D5, we get out Hershey bar. Okay. What's another example of an input we could use?
D8.
D8. If we put in D8, what are we going to get out? Amounts. All right. If we put in D8, would we ever get a Heath bar out?
No.
If this were a perfectly working vending machine. No. So what I want you to do with the rest of your group members is to figure out whether the rest of these vending machines, when you put in the input, will give you exactly one output back. Okay? Go ahead, take 3 minutes to do that, please.
What is you talking about? Okay.
So you will know. So looking here, if you put in, what would an input be?
A6.
Okay, if you put in A6, what are you going to get out?
A Gatorade or whatever.
You get a light water, okay? If you put in A6, you can get out a Pepsi?
No.
No. So if you put in A6, you know you're only going to get out life water. So you will know what you get out, okay?
So what do we write? Yes or no on top of it?
Yeah, yes or no.
Oh, okay. Oh, we can write on this?
Yes, you can write on the photos. Like yes or no.
Mm-hmm.
Okay. What about this one?
So, okay. That's it.
Maybe give an example of what an input would be and what the outputs would be, okay?
Okay,
Like here, what's the input of that? What are you going to put in? You just put in 25 cents, but what are you going to get out?
Any color.
Any color, okay? Here, what's the input? 25 cents, but what do you get out? An array, right, an array of objects, like a soccer ball at the top. If you put in D4, would you get Reese's out? Would you get a Twix out? What's the only thing you're going to get out if you put in D4? Oreos. Okay. All right. Is everyone done labeling whether or not they'll know the input-output for those vending machines? Yes? All right. Then let's take a look at number 2. Vending machine number 2. How did you all label that one? Let's hear from Denisha's group.
Vending machine number 2, we said yes.
Yeah. Why did you say yes?
Because if you were to, whatever you want, you put it in and you'll get the exact thing.
Okay, give an example. Like, what would we put in? What thing would we get?
Like if I put in B6,
okay, put in
I get the Sierra Mist.
Okay. All right. What about the bubble gum? LaChrista's team. What about the bubble gum machine?
No.
No. Why do we say no to bubble gum?
Because when you put in something, you don't know what you're gonna get.
Well, what's the input gonna be?
The quarter.
The quarter. We're always gonna put in 25 cents, But what could we get out for 25 cents?
Blue.
Okay, hold up. We could get out blue. What else could we get?
Yellow, white,
Orange, yellow, white,
pink, purple,
purple.
red.
Okay. So how many different outputs does 25 cents have?
4.
4.
Just more than one.
Or as many colors that are in our gumball machine. Okay, let's take a look at this vending machine. What's the input for number 4?
25.
25 cents. But Travis, what's one output we could get?
A little soccer ball.
Okay, we might get a little soccer ball. Alright. Kaij, what's a different output we could get? A dice. Okay. Does anyone see
A basketball.
a basketball?
Y'all got a soccer ball? Oh, yeah.
Okay. And then
Eyeball.
lastly, let's talk about number 5. What did you all say about vending machine 5?
Yes.
Yes. And let's have an example of an input from Reggie.
C4.
Okay, we put in C4, and what are we going to get out?
The grandma's cookies.
Okay. If you put in C4, are you going to get out Grandma's Cookies or Chips Ahoy?
No.
No. What do you know you're going to get out when you put in C4?
Grandma's cookies.
Grandma's Cookies. All right. So let's go ahead, take out that note sheet. So what we can say is a function is a special relationship between two values. And more to that, each input will have, yes, exactly one output. Okay? So for a function, when you have an input, you should get only one output back. All right? So now, with that information, let's go ahead and just label our vending machines on whether or not they're functions. So for vending machine number 1, would we say it's a function or not a function? Function. Why? Why do we know it's a function?
Each input has one.
Okay, yeah, so we can say vending number 1 is a function. All right, what about vending number 2?
Yes.
Yep, function. What about vending number 3?
No.
No. What's wrong with vending number 3?
Because you put in something, but you don't know if you can get out.
Yeah, we put in 25 cents and we either could get blue, orange, yellow, white, purple, pink. You put in one input and it has a various amount of different outputs, okay? What about vending machine number 4?
No.
No. Pretty similar case to vending machine number 1. We put in a quarter, but we could get out a basketball, a soccer ball, a top, or a dime. What about vending machine number 5?
Yes.
Yes. We put in C4, what do we know we're going to get, Travis?
Grandma's cookies.
We're going to get Grandma's Cookies, okay? We put in D4, what do we know we're going to get out?
Oh, yeah.
All right.
No.
Oh, yeah.
All right, so let's go back to the note sheet. So now we can take a look at the domain is the set of all inputs. The range is the set of all outputs. Okay. And then whenever you see an ordered pair, whenever you see two numbers next to each other with a parenthesis in between them, it's written as input first, output second. Okay? Alright. So now let's move away from vending machines and apply our knowledge of functions, of domain, of range, to a table of values. Okay? So looking at this table of values down here, we're asked, does the table represent a function?
Yes.
So Shemaiah says yes. Shemaiah, why does this table represent a function?
Because each input has one output.
Okay. So each input has exactly one output. Okay. So do a check, Reggie. When we put in 2, what are we going to get out?
18.
Okay. Amelia, when we put in 4, what will we get out?
20.
Okay. When we put in 6, what are we going to get out, Kaija?
15.
And LaCrystal, when we put in 7, what do we get out?
9.
Okay. And what we can do is we can take all these numbers from the table and then create ordered pairs. We have 2, 18, 4, 20, 6, 14, and 7, 9. Now we're asked, what is a domain? Well, is a domain input or output, Amelia?
Input.
Okay. So let's list all of our inputs right here. What were our inputs, Reggie?
2, 4, 6, 7.
2, 4, 6, 7. And then our range, we know, is a set of outputs. What are all the outputs we have with Krista?
18, 20, 14, and 9.
Yeah, 18, 20, 14, and 9. Okay. All right. Well, now let's do one last example. Looking at the ordered pairs at the bottom,
Not a function.
do the following set of numbers represent a function?
No. No.
No.
Because the
So
input.
Shemaiah is going to explain to us why the following ordered pairs do not represent a function.
Because the input 2 has 2 different outputs.
When we put in 2, what are those 2 outputs we could get?
5 and 6.
Right, we either could get 5 or 6. This example is more like the bubblegum machine. You put in a quarter, you could get out a lot of different colors. With this, we put in 2, we either could get 5 or 6, which violates our rule of a function, which says that each input has exactly one output. So we could say no, not a function, input 2 has 2 different outputs. But we can still write the domain. Chicago, can you tell us what the domain is?
2, 3, 2, 4, 5.
2, 3, 2, 4, and 5. Those are all of our inputs. And then Travis, what would our range be?
5, 7, 6, 8, and 9.
And those represent all of our outputs. And that is all. Can I say cut?
Cut.
All right, so thank you very much for watching this video. What we learned today was that a function is a special relationship between 2 values where the input has exactly one output. The domain is a set of all inputs and the range is a set of all outputs. Thanks again.
Ooh, wait, good God, let me think about it. Well, you can tell by the way I use my walk, I'm a woman's man, no time for talk. Music loud and love and warm, been trying to figure it out since I was born. You know it's alright, it's okay, if you believe another way. You can try to understand this new age world effect on man. Whether you're a mother or whether you're a brother, you're still alive.